Okay, we are live again, finishing up on the CKS studies today. I've been going through the course and I finished the video course finally. The last 3 hours were a bit of a slog. It's an 11-hour course and the last 3 hours were, I was feeling it, but I'm through it. But to be honest, I didn't do all of the Killercoda scenarios in those last 3 hours. So now I'm going to finish them all up and get all these wonderful check marks here. And it's going to be fun to see how much of the video watching actually stuck and to see if I can actually manage to fix these challenges as I'm going along. Hey there, Anson. Welcome to the stream. So, without further ado, let's start the first one about AppArmor. So if I understood it correctly, AppArmor is like a way of restricting the things that containers can do on your operating system. Check existing AppArmor profiles. All right. You're asked to verify the following AppArmor profiles available on node 1. So I'm now on the control plane. So I'll have to first, always start with tmux and set-ovi. That's just the first thing I always do in these scenarios. And let's check node 1, SSH node 01. And then these AppArmor profiles. Is it etc app? Yeah, AppArmor.d. All right. And then it's going to be local. Here. So here we have the AppArmor profiles, I think. Docker default, snap. No, it's not. Tunables, force complaint. Interesting. Is there another directory? cd AppArmor. Maybe it's just AppArmor. Init. No. You've asked to verify if the following AppArmor profiles are available on node 01. Oh. It should only contain the profile names that are available on node 1. So let's check out the ones that are on control plane. cd etc AppArmor. And let's check. Oh, wait, they're already here. Like these are the profiles probably. User bin Firefox, user bin man. So let's open up vim user bin Firefox. Yeah, this is an AppArmor profile. Yeah, profile Firefox. Here we go. Okay. So these are the profiles. These are the ones on the control plane. And let's go back. cd etc AppArmor.d. Okay, so these are all the ones that are available on node 01. You're asked to verify if the following AppArmor profiles are available on node 01. Well, Docker default is not here. Snap is not here either. FTPD is also not here. Well, maybe I should find dot and then let's see, grab Docker. Nothing there. And is there anything on the control plane? Find dot grab Docker. No. So is the answer that none of them are available here? TCP dump? Is that one here? Yeah, TCP dump is available here. Nothing about FTP. So I think it's all of these actually. It should only contain these profiles names that are available on node 1. Well, then it's user bin TCP dump. And then go to vim root profiles.txt. I think it's only that one actually. Let's check. And I'm wrong. So, what is the... How would one find the rest of these profiles? FTPD. Find dot grab FTPD. Nothing. Grab FTPD. Can we find something then? Is there anything in local? Oh wait, there's probably more in local too. So let's go into local then. In the control plane. In local there's also more. So is there... There is something about snap here. Is that on node 01? Snapd is here as well. Okay, so snapd we also need to add, I suppose. Copy. Vim. Snap. That one was there too. Check. Still not. Okay, I'm just gonna look at the solution because... Oh, AppArmor status, of course. Yeah. AppArmor. I was going the file route, whereas I should have just ran the command, and then it would have been very easy to just AppArmor status and then pipe that to less. And now I could have searched for Docker, and here I would see Docker default. Yeah, all right. I was just an idiot. Okay, well, that's how you learn, right? You make mistakes. So Docker is here. Well, I was not far actually. So the only one that I was missing was Docker. So where is Docker then? fd find dot type f name Docker. Nothing about Docker. It is one of these ones that are installed by default. ls tunables. Well, anyway, Docker was the only one that I was missing, I think. So if I open this one again and I add Docker and check, then it's successful. Okay. Next, there's an existing deployment named SpaceCow in namespace moon. It should be configured to use AppArmor profile Docker default, but something seems wrong. Fix it. Okay, so we are going to check out and moon, edit, deploy, SpaceCow. And then there is... It should be configured to use AppArmor profile Docker default, but something seems wrong. Well, I don't see any label with AppArmor because that's how you do it. You basically add an annotation to it. AppArmor. Restricted containers access to resources with AppArmor. Okay. Here you go. They're specified per container, and to specify the profile, add an annotation to the pod's metadata. But that's strange. It should be configured to use AppArmor profile, but something seems wrong. That implies that it has this annotation, but that they misconfigured it or that the profile is missing. Oh, here we go. Here is the thing. Why didn't it come up earlier? Oh well. Container AppArmor security beta. Let's check out if that matches. Container AppArmor security beta Kubernetes IO /container. Okay, so it's not referring to the right container name. So there's only one container in this deployment. It only has the one in the list. So the name is HTTPD. So this needs to be changed to HTTPD. This one can be deleted. And if I now delete it, then moon get pods. It's actually not redeploying. That's interesting. But maybe it doesn't need to be. Oh, I should probably enable screen keys here. There we go. Okay. So, hello, Nikos. Welcome to the stream. Nikos, I hope I pronounced that correctly. So I've edited the deployment, and let's just verify that the annotation is correct. Yeah. So let's check it. No, it failed. So I edited the deployment. Let's see if the localhost Docker default. Let's see if the deployment actually is available. So first, let's check where the pods are actually running. Get pods n moon o wide. So they're all on node 01. So that's where I will need to be looking. And on my node 1, I couldn't find the Docker default. So it needs to have the Docker default there. So let's see if we can find this file on the control plane. etc AppArmor.d. And then find dot name Docker. There's nothing about Docker here. Where is the Docker default profile usually located on a system? cd etc AppArmor. Wait, maybe I can. What was it? AppArmor status. Grab Docker. No, pipe that to less. And then search for Docker. Here, Docker default. So it is here. Now, is there like a AppArmor AppArmor parser? Status. No. It would be nice if I could figure out from the CLI where the profile is located, because etc AppArmor, I seem to be unable to locate the Docker default file for some reason. There's nothing here. And then in etc AppArmor.d grep doc. There's also nothing about Docker. So why is that profile not available here? Well, at least the file name is not here. It's not, the file is not named Docker. So if I just tree this, or just find dot and pipe that to less, what do we see? We see disabled tunables. Then we have NVIDIA. These are all abstractions. Is there anything about Docker here? No. Default, no. This is all. If I search this for Docker, it's not here. Not in the control plane. And cd etc AppArmor.d. Find dot. Pipe that to less. There's nothing about Docker here either. So that's really strange. Where is that file then? Well, I gotta look at the solution. The AppArmor profile will be configured via annotation. Yep, that's correct. Yeah, well, that's what I've done, right? I've done this. Well, wait. K8s deploy. And moon. Space cow. Oh, okay. I've added it to the deployment level. So I have to take this line and then add it to the spec or the template level. So just get this whole block of annotations under metadata. Okay, indent this, remove this one. So now that's also why the deployment was not redeploying. And if I now get the pods in namespace moon, yeah, now they've all redeployed. And if I check now, yeah, these are these dangerous little rabbit holes that you can get into. Like now I was poking around the file system. And sure, I've now learned that I can't actually see the Docker default file. So it has been useful, but these are not the kind of things that you want to be doing on these timed exams, right? That's going to be real dangerous time sinks. There's an AppArmor profile as root profile. It should be referenced by the name Docker Nginx custom, installed on nodes control plane and node 01. Sure. You got it. I can do this. I can do this. I'm failing, but I'm learning. I shouldn't be afraid to fail. There's an AppArmor profile at root profile, cd root. Yeah, cat profile. All right, this is a big file. Vim profile. Profile Docker Nginx. It should be referenced by name Docker Nginx custom. Well, that's easy. It should just be called that then. And then Nginx, Docker Nginx. Check if there are more references. Docker Nginx. Nope. No more references. So that should be it then. And it should be referenced by name Docker Nginx custom, installed on nodes control plane and node 01. So I will copy the file profile to etc AppArmor.d and call it Docker Nginx custom. And then there is this command AppArmor parser. So now it should parse that directory. And then I should see the profile in AppArmor status. It's taking a long time, so that is worrying me. Okay, something is wrong. AppArmor status, do we see anything here? "37 profiles are loaded. Is there anything about Nginx? No. So it's probably running into a problem here. AppArmor parser. So what can I have done wrong? cd etc AppArmor.d. Maybe I should move it to local. Yeah, let's try that. Move Docker Nginx custom to local. Why is that lighting up differently? LSLA. Oh, it has different permissions. Read, write, X, read, XR. So it should be readable. Cat Docker Nginx custom. Yeah. So now if I do AppArmor parse it again. Nope, not working. Do I see anything in the syslogs about this? Journal CTL. AppArmor. No. Okay. Well, this scenario has not gone well for me. I've had to look at all of the solutions all the time. But hey, that's how you learn. I give up now. Tip. The following line sets to this profile's name Docker Nginx. Yeah. Well, that's what I've changed. So vim docker nginx custom. Here's the different file name that I created. Oh. Wait, you have to give it the directory? Really? Is that what I was doing wrong? AppArmor parser and then etc AppArmor.d. Okay, so now it added it. If I now do AppArmor status and then grep for Nginx, it's not added though, because I had it in the local folder. Yep, now it's in the Nginx. So if I grab it now, Docker, Nginx custom, and that's now active. All right, so now it works. So now I just need to copy that over to node 1. So then scp Docker Nginx custom to node 1 slash etc AppArmor.d local. Could not resolve node name node 01. Of course, node 01 set-ovi. And if I now go over to node 1 in the local directory, we now have our Docker Nginx custom. And if I then AppArmor parser, if I do dot, will that work? Yep, now it worked. And if I then AppArmor status, and grab that for Docker. Here we go. Here's Docker Nginx custom. So what did I learn? I learned quite a lot from doing this one. Let's see. If I open up my CKS course notes, and I'm going to be adding that to, where shall I call it? Containers, admission controller. Well, I'll just make another entry here. And call that AppArmor, used to restrict processes. Must know AppArmor status, AppArmor parser. Important, must give path to AppArmor parser. Also make sure to add the label to the pod spec and not deployment spec. Okay. So now they should be solved. Yeah, validation successful. All right, back to the scenarios. I realized I didn't start a Pomodoro timer. I can see I've been live for 28 minutes. So I'll do one more scenario and then I'm gonna have a little break. Man, 38, that was 20, like that was almost half an hour on one scenario. And of course I'm still learning, but you don't want to be in this kind of situation in the exam, you know, then you're going to be in big trouble. So definitely a scenario to repeat. Actually, I have a note on that, scenarios to repeat. etcd encryption, that was fun. But let's add AppArmor here. That's definitely didn't go smooth, so gonna do that more. Let's do auditing, enable audit logging. I remember that was quite straightforward, but let's see. Start with tmux and then set-ovi. First thing I do. Configure the API server for audit logging. the log path should be etc Kubernetes audit logs. Audit log on the host and inside the container. The existing audit policy to use is here. The path should be the same on the host and inside the container. Okay. So audit log. I think that's in the Kube API server. Auditing, yeah, audit policy. So these are the policies that are there. Yeah. Yeah. Okay, that's how we need to configure the volumes. And now let's check the Kube API server for the right flag. Audit. These are all just configuration strings, but is there also one for allowing it? Webhook config file. These are all just parameters, like how to configure it. But isn't there like what audit logging enabled, or where the config file is? I only see a webhook config file. Okay, so let's see what the API server manifest looks like now. cd etc manifests, etc Kubernetes manifests, and check out the Kube API server. Nothing about audit logging here. The log path should be etc Kubernetes audit logs. So is there anything about log path here? Log batch, log compress format, max size mode. Here's the audit policy configuration. Ah, here, audit policy file. I think that's the one we need, because probably in the probably in the policy is defined where the log should be. So create a new window, and then let's check out the policy file. Vim etc policy.yaml. No, this is just the YAML file. Okay, I'm almost there. I have this parameter, audit policy file. But let's just start with that one. Nothing else here. So I'm going to add the flag audit policy file. That one is this one, the etc Kubernetes audit policy. That's for sure. And is there anything about log in here? No. Ah, audit log path. Here we go. Audit log path. That's it. So audit log path. Audit log path needs to be this. Then we need to add the volume. And we saw that in the previous one. Oh yeah, this is a nice type file. Okay, that's a nice example. Nice of them to add that here. So we have a volume here, and we'll call that audit policy. The path is policy.yaml here. Oops. Okay. And then we have to make a volume mount of audit policy up here. Mount path name audit policy, and that needs to be on the same location. Okay, no, here. There we go. Audit policy. And here we go. That was the policy file. And then the audit log is just a directory. And this one, they want to have it as a particular file. So that's interesting. The log path should be at Kubernetes logs audit.log. And what do I say here? Audit log path. Well, I wonder if I'm going to try as a file, right? But maybe it will just create the file named audit.log at that location, and I have to mount it as a directory. But let's just try it like this. Also going to mount this as a file, and then have a volume mount at the same location. We call that audit log. And here they're saying read only false. So does this say anything about... Oh. Okay. Yeah, so it's telling it to... Okay. Yeah. Here it's already configured like this, so I just follow exactly what is here. So here I don't change anything, but the type is directory or create, just like it is in the documentation. So going back down to this one here. Okay. So audit policy and audit log. Audit policy and audit log. This should be it. K8s pods. API server is down, so that means that it's being restarted. So I'm going to watch N1 CRI CTL PS. The API server is currently not up, so I must have broken something. And then let's check out var log pod. And then check out the kube system API server. Let's see. Error, unknown flag, audit log path. Okay, Let's see. Kubernetes manifests. I'm forgetting the equal signs. Close that. See if that changes anything. I might have to move the file back and forth. I'm just gonna give it a little bit of time. Maybe it will detect a change. Yeah, here we go. And it instantly closed. Insta-close. Insta-close. So, vim q cd cube API server. What does it say now? Audit logs, audit.log is a directory. Okay. Vim cube API server. Yep. Here, this flag is wrong. It should just be audit logs probably. Let's check the documentation. No. Huh? Oh, wait. Yeah, this should be audit.log. But the mount should be /audit. /audit. And then this should also be just /audit. Here we go. Now it should work. Let's check it out. Give it a few seconds. If not, I will just move the file. So move cube API server to the previous directory, and then I move it back again. That should trigger a restart. Oh, come on, man. Are you just teasing me? Calico has restarted. Hey, Mikola. Nice to see you. Let's see if there are some new logs then. CD cube system cube API server. Oh, number 4. So we are definitely moving up. Open /c Kubernetes audit logs. Audit.log is a directory. What do you mean it's a directory? Vim cube API server.yaml. I've done it exactly like here. Audit log path. Audit log path. That needs to be like this. Var log Kubernetes audit.log. Oh, wait. Aha. The log path should be @c Kubernetes. Maybe I was messing up those paths. @c Kubernetes audit logs audit.log. Mount path @c Kubernetes audit logs. Mount path @c Kubernetes /audit. But I have it as audit logs. And then down here, I also have it as @c Kubernetes audit logs. So that seems correct to me. They're both host path @c Kubernetes audit logs. @c Kubernetes audit logs is the volume. It is a host path. So that's correct. Then the mount path is @c Kubernetes audit logs. Read only false. So it should be able to write. And then here, the audit log path is @c Kubernetes audit logs /audit.log. Is it maybe because @c Kubernetes cd audit logs? Wait, there is, I think because what I did wrong just now, it created a directory at that location on the node. So if there's nothing in this directory, this is just a directory. So if I remove this directory, okay, now the directory is gone, and now when the pod restarts, something different must happen. This must be it. This must be it. So here we go. Kube API server is running. 6 seconds. Oh, that was a weird one. And like these are these moments where I'm really happy that I have a solid understanding of Linux, because like what are you gonna do? Like I knew I needed to check out that path on the system and check out if something was wrong there, because I had this strange error message saying that this is a directory. Like, oh, I'm so glad that I figured that out. So if I check now, the validation failed, but at least the API server is coming up. So I'm almost there. So what I am missing now is these 2 flags where I am setting the max size. So we're going to add those. And finally, we're going to add this one, max backup. Here we go. Now the API server should restart in a few moments with the new flags. It's not restarting yet, but maybe it's just finishing some requests or something. Or I might have to change the file. Or move the file, I mean. No, here he goes. Here goes the Kube API server. It's back up. It's staying up. Okay, get pods. It's up. Check. Successful. Yes, I did it. I'm not a complete donkey, but it was, again, a bit of too much stumbling around. Oh well. Well, there was 2 scenarios. So I've done the AppArmor, that's checked off. The audit log. What is the next one? These ones I've done. These ones I've done. Falco change rule. All right. So I'm going to take a short break. I'll be back in 5 or 10 minutes, and probably 5 minutes or so. And then I will do the Falco scenario. And that is actually one of the few, and then there are a few more scenarios that I still need to do, but I'm getting close. All right, short break, and then I'll be back soon. 5 or 10 minutes. Start break. All right, be right back. So we're back again, and I'm holding my hand up to the camera because then it starts tracking my face. This is like the signal for it to start tracking it. So, are you ready for another round of Killercoda? Let's do it. Let's get into Falco. And actually now I am going to start a POMO. So Falco, change rule. And again, like I said, I've watched the last 4 hours of the course without doing any of the scenarios. And now I'm just testing how much of that information I've actually retained, just as an experiment. tmux set-ovi start. Falco has been installed on node control plane and it runs as a service. It's configured to log to syslog, and this is where the verification for this scenario also looks. Cause the rule shell in a container to log by creating a new pod, execing it, and then check the Falco logs container related output. So, run nginx, image is nginx alpine, exec nginx shell. I shelled, but I didn't exec in interactive mode. But then let's see, configure to log to syslog. So opening a new pane window, I'm going to go into journal CTL. Check here and here. Error, package manage process launched in container user root nginx container. So here is something here. Falco. Interestingly, it said package management process launched in container, but it is the container name nginx container ID. Yeah, it should be that one. Like that was not so long ago. So here we saw the log entry. So let's check it. Oh, it failed. Let's try it again. Like I'm now in the shell. So do I see any output of that here? Journal CTL. Here, notice a shell was spawned in a container with attached terminal. Ah, okay, maybe that was the problem. I didn't do it in interactive mode. So now it's validated. Okay. Change the Falco output of rule terminal shell in container to include new shell at the very beginning. Yada yada. Sure. So then we have to modify the Falco rule. So let's go to etc Falco, I think. Falco. I love Linux. All of the configuration is in etc. It's just so predictable and you always know exactly where to go. I love it. There is a rules.d, so that means a directory containing all of the rules. It's probably the Falco rules local. So vim Falco rules local.yaml. It's not that one. Then it's just Falco rules.yaml. And then we had something about shell binaries. Modify shell configuration file. Wait, let's journal CTL. What was it? Falco. Here. A shell was spawned. So let's search for spawned in the file. Spawned. Oh. A shell was spawned. Here. Output. A shell was spawned in a container with an attached terminal. Here we go. Output. Yeah. So include new shell at the very beginning. New shell. And then include user ID at any position. So let's just put that on the end then. And then include repo container image repository at any position. Sure. So that's now added. Cause syslog output again by creating a shell in that pod. So I'm out of the pod again, and then I'm going to run that command again to trigger the rule, journal CTL. And then here we see the new, you can see it down here. My head is not covering it. New shell, a shell was spawned. And then I'm trusting that here the user ID is 0 and repo docker IO is library. I'm covering it, but you trust me, it's there. So it should, now it should, yeah, it should validate correctly. Challenge solved. Well, that was easy. There was a lot less stumbling around than the previous ones. Dear God. Okay. Back to the scenarios. And I just love it that it shows the check mark here. I love that so much, to see all these check marks and to know that I have done them. Yeah, I love lists and I love ticking off lists. Here we go. Here's another one that I haven't done yet. Immutability of a read-only file system. Create workloads with a read-only file system. Let's do it. Yeah. Tmux set-ovi. Create a pod named pod row. Yeah, so k run named pod row. Image is busybox yada yada. And then is it command? I think you can say command to a pod less and then command. Yeah, this is so handy. Command dash command arg. Okay, so that's really useful. Okay, run pod and then command dash and then it's going to be sleep 1 day and then OYAML dry run is client and save that in pod.yaml, and it needs to be ran in the namespace sun. Hey, why didn't it do a dry run? That's weird. delete pod n sun pod row. Oh, I see. Okay, I have to do the dry run client stuff. That needs to be done before the command, because now I'm actually including that in the command. All right. Dry run is client. Oh, YAML. Now I have my pod YAML. All right. Namespace sun, containers, command, sleep 1 day. That is all looking smooth. And then the container root file system should be read only. And that is done by security. And let me see, pod security context. Configure a security context for a pod or container. And then read-only root file system should be set to true. So here we have the spec security context. I'm just going to copy that. Spec security context. And then read-only file system true. Apply fpod.yaml. Unknown field in spec security context. Really? Or maybe it's enabled true. So let's check out the API spec. Oh, security context. Read-only root file system is a Boolean. So that should just... Oh, it's on the container level. Oops. Oopsie daisy. So containers, and then it's on the container level. Huh? Okay, delete pod and sun. Let's apply it again. And now it was created properly. So let's check it. And the validation is successful. And now it enters a new one in the scenario. Fix existing Nginx deployment to work with read-only file system. Add an empty dir volume to fix this. What was that again? An empty dir and then a read-only file system. What was that about? Empty dir. Okay. That's new to me. Add an empty dir volume to fix this. Well, let's check out the deployment first. Okay, and moon, edit, deploy, web4. Oh, it's not even configured with read-only file system. Yeah, so, here. Security context, read-only file system is true. Sure. It doesn't seem to work. Okay, describe pod n moon. So what is the problem with this one then? Just out of curiosity. Failed. So the container is failing. Just gives a crash loop back off. So K logs deployments and moon. Oh, okay. Yeah. So the logs are saying I can't create etc.date.log because it's a read-only file system. Now I get it. Now I get the assignment. So it is trying to create a file, but since it's a read-only file system, it's not able to create it. So I have to create an empty directory so that it's allowed to write there. Gotcha. So then what we do is we check out concepts and then containers. No. Isn't it concept storage? Here, storage. Volumes. Persistent volumes. No, just volumes. Empty dir. And here is an example of it. Empty dir. So let's edit the deployment. We're going to go down to the spec of the pods. Volume mounts happens on the container level. Mount path is going to be at C. And the name can just be cache volume. And then the volumes need to be on the pod level here. Invalid spec. Spec template volumes. Okay, so it needs to be indented one to the right. It's edited. So if I now describe the pods, started the container, it's working, and it has the empty dir volume. And if I check it now, the validation is successful and the challenge is solved. Yay. Next scenario. Done, 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 done. Seeing all these beautiful check marks. I'm at the very bottom of the scenarios here. It's actually 1, 2, 3, 4 more scenarios to go. And let's start with the static manual analysis of Docker. Wonder what this one is about. Oh, I've done this. I've already done this scenario. Tmux set-ovi. I forget what the tool is that you need to use though. It's not Trivy, that's for the images. What is the tool that they want me to use again? Oh, I forget. I hope I can find static analysis here. Static analysis. Ooh, that's really bad that I forgot the name of the tool. Tip. What's it called? Yeah, okay, you're saying... Oh, it's a manual static analysis. Oh, I thought it was like there's a scenario about a tool where you have to perform an analysis of the Docker files, and I forgot what the name was. So I haven't done this one. So you're just supposed to check out the Docker files. So I haven't read the thing. It's just, I haven't read the solution. It's just saying which one of these is, of app 1 is less secure. That's basically what they're asking. So let's see, do I see something here? If I open root apps, app 1, and then 9 here. So comparing these, which one of these is less secure? Well, this one has only one stage. This is just so this is running as the Ubuntu image. And this one actually goes to Alpine. They're both running as root. So they're both insecure in that sense. But since this is a more minimal image, then that's probably the less secure one. Or the more secure one, because Ubuntu contains more binaries and therefore a larger attack surface. So move the less secure file. That will be this one because, no, the other one. This is the Ubuntu one. This is the less secure one. So move this one to root insecure. Check. Successful. Perform. Okay, so it just wants you to do manual analysis of these. So analyze them yourself. So move. Actually, I'm going to open two tmux windows side by side. cd root apps. Or maybe I can just do vim diff vimd root apps app2. Okay. This is a nice way to see the difference. And I just globbed them. Did you see what I did? vimd and then the path and then just app2 star. And then I get all of the app2 files and I get them side by side in one command. It's really neat. So move the less secure file. Well, this one is running as user app user. So this is definitely more secure. This is 27 and this is 5C. So the 5C one has got to go. Move root apps app2 and then 5C to root insecure. Check. Done. And then we're going to do the same trick for app3 star. Here we go. Let's see. Which one of these is less secure? So the left one runs a shell script with a environment variable, and that is accepted to the script as a argument. The right side echoes a secret token into a file. It must be the right one because the echo is going to put that into the logs. I'm betting it's the right one. 404. So move root apps app3 404 to root insecure. Check. Yay! Fixed it. Back to the scenarios. And now we have only 3 left. So what do we want to do first? strace, that's fun. Close and open ports. Or managing packages. This all sounds very Linuxy. These shouldn't be too difficult. Let's do the strace. Full CKS course. All right, use strace to see which syscalls the following commands perform. First, we're going to open tmux and set -ovi like all the time, and then strace this. Okay, so here we see all of the syscalls that these processes do. Strace uname. Like it's not actually checking. I think I can just go next. So use strace to see what kind of syscalls the Kube API server process performs. This is more interesting. So first, figuring out what the Kube API server process is. So that's ps aux grep API. Here we see the Kube API server here. So that's PID 223. And then it's strace is it strace P, yeah. So strace P 2223. So now I'm attached to that process. And if I now say do a k run pod, k run nginx images nginx. Oh, I thought I would actually stream that, but I did not. Let's see. So let's check out the logs then of the help again. Pipe to less. Is there anything like follow? Trace process with PID may be repeated. Signal trace a path. Tempering. Yeah, I mean, trace a path. Could do that with the location of the pod, theoretically. But I think this should be it. But it's interesting that it wasn't doing any syscalls as I was running a pod. So let's check out what the solution was. Yeah, I did that. Ah, so you have to do F. Yeah, I was thinking of it, but F. Here we go. Now we see all of the syscalls that the Kube API server process is doing. Yeah. Okay, so then -CW. Then you wait for a bit, abort, and here we see a bit of a nicer output of it. So it has been doing few texts 1,005 times. ePol wait, nano sleep, right. It's doing a lot of things, this API server of ours. All right, it's solved. System hardening, close and open ports. That's going to be net statting. Tmux set-OVI, the superior editing mode for the elites. There's an unwanted process running which listens on port 123. Kill the process and delete the binary. All right, so netstat-tulpen. And I remember that because tulpen is the Dutch word for tulips. That's how I've remembered it. And do I see it with the naked eye? Not yet, but if I grep for 1, 2, 3, 4, here I see this is the process. It's called app1. So ps aux grep. Here is the process, and here I see that this is the binary. So I need to delete this binary, but first I need to kill. It's called, I think the command is pkill, and then enter the process number. So now it's killed. If I now do, oh, it's not killed yet. Well, then I will just do kill. Kill. Now it's killed. And then I will delete the binary, rmf, and then the bin app1. Done. Check. Successful. Challenge solved. Well, that was easy. If the CKS exam was only this, then I would be flying through it. Back to the scenarios. And wow, that's just one more left, guys. One more scenario left. System hardening, manage packages. Remove and stop different services. Well, that shouldn't be much of a problem. I'm actually surprised. Like, I've now gone through the entire CKS course, and I thought it would be really hard. And I thought it would be very hard on the Linux level. But actually, in terms of Linux, I've done much harder things when I was building my Arch Linux system a while back that I had for a daily driver for a long time. Like, that experience has made this so much easier. But it's like you need to know Linux for the CKS. But I'm surprised how far I've come without any further studies on the Linux level. Tmux set-ovi. Start. Remove the kube bench package. Okay, so go ahead and remove the kube bench package using the default package manager. So sudo apt remove kube bench. Okay. Validation successful. VSFTPD has been installed. Don't uninstall it, just stop the service. Sudo systemctl stop VSFTPD service. Hello. Check. Done and already solved. Wow. I've done all of the scenarios for KillerSH or Killercoda. And hereby my official studies for the CKS are concluded, actually. I've gone through all of the material. I've done all the scenarios. And yeah, there are a few ones that I need to repeat, but I have a fair understanding of what the exam is going to be about. So actually, I'm going to be ordering my exam this week. I'm going to order it, and then the next weekend, I'm going to just do KillerSH over and over and over and over again, like I did for the CKA. I literally did it maybe 8 times or something, like serious 2 12-hour days in one weekend of just KillerSH, and I could dream that exam, and I passed. And I'm going to do the same for the CKS. So that was cool. So I started this stream with AppArmor, and I was stumbling around a lot. That was not fun at all. So let's see if I can fix that a little bit more quickly this time around. Tmux set-ovi start. You're asked to verify if the following AppArmor profiles are available on node 01. SSH node 01 and then AppArmor status. Pipe that to less. Do we have Docker default? Yes, we do. Do we have snap.lx? Yes, we do. Do we have FTPD? We do not have FTPD. Do we have TCP dump? We have TCP dump. And do we have FTPD? No. So create, it should only contain these profile names that are available on node 1. So we have all of these except for FTPD. And then on control plane, create the file vim root profiles.txt. It should only contain the profile names that are available on node 01. So that should be all of these. Except for FTPD. Save that, check. Successful. That took me like, what, 20 minutes the first time around. There's an existing deployment named SpaceCow in namespace moon. It should be configured to use AppArmor profile Docker default, but something seems wrong. Sure. K n moon edit deploy SpaceCow. Edit deploy SpaceCow. And here it was that the annotation was, firstly, it should be this annotation should contain the container name and not container. So down here I see the name of the container is HTTPD. So we're going to change this to HTTPD. And this annotation also needs to be attached on the container spec. Or the pod spec, I should say. So here the metadata should contain annotations. Here. So if I now kn moon get pods, it should restart. And all of the pods have now been restarted. And if I validate, it's successful. Now, there is an AppArmor profile at root profile. It should be referenced by name Docker Nginx custom and change the profile if needed. Install it on the nodes control plane and node 01. So this is where I was mucking about with this directory that had been created. That was really annoying. Oh no, wait, no, that was the audit logging. Actually, this is just adding it to the directory and then running parser. And then you have to run the parser in the directory. That's what I learned. You can't just run a queue-parser. You have to give the path where to run it. So there's an AppArmor profile at root profile. cd root. Here's the profile. We're going to adjust it so the name is Docker Nginx -custom. Yes. And then we are going to copy the profile to etc AppArmor.d. And then I will just add it to the root directory of AppArmor and call it Docker Nginx custom. And then I'm going to run AppArmor parser and give it the path AppArmor.d. And if I now do AppArmor status and then grep for Nginx, our Docker Nginx custom is there. So I'm going to do the same trick. I'm going to, let's see, clear scp this file to node 01 and that directory. That has been transferred now. SSH node 1. And then AppArmor parser. And then give it the AppArmor.d directory. And then AppArmor status. grep nginx. Here we go. Check it, and it's done. What was that? 5 minutes? Less than 5 minutes? I can do it. I just have to get the practice. So I've learned a lot today. I've learned these were good sessions. These were good. This is why these Killercoda scenarios are just invaluable. So I'm so grateful that all of this is available out there. It's just awesome. It's just really awesome. So wow, I have now officially finished all of the CKS scenarios. I'm going to be practicing more and more in the coming week. And I'm going to, especially the network policies and the RBAC, those are the two ones that I'm going to keep working on. I've become much better at them. So I am quite confident that I can do it on the exam. I've definitely practiced a lot with those. So maybe I'll do another stream in the coming week where I practice those. And yeah, I feel quite ready, guys. Ready for taking the killer SH for at least. So yeah, I think I'm gonna end the stream here. I feel good about these 2 hours of practice. Thank you so much for tuning in, and I hope to see you in the next one. Bye bye.